Welcome, everybody. It's Kotlin again. You're back to our uh, famous YouTube channel, and we're going to talk about creative coding again. Last time we started with creative coding in Kotlin using Jetpack Compose. That was an introductory session into generative programming, and I received a lot of feedback from people who watched it, and I apparently motivated some of the folks to start trying stuff and generating some nice visuals. And today we continue because this topic is pretty broad. There are lots of tools, lots of programming languages that you can apply for this task, and today our topic is OpenRender, which is a framework and a library for coding in Kotlin. And we have Edwin Jakobs, who is the maintainer and creator of this project, and he's going to do some live demos for us today. Hello, Edwin.
Hi. Thanks for
Hi.
having me.
Yeah,
Yeah,
like I saw the project like a year ago, and I thought this is something we have to try. And we weren't focused that much on creative coding, and apparently we are getting into this land now with all the webinars we are organizing. So everybody, if you have any questions during the session, don't hesitate to ask. I will interrupt Edwin at any point of time whenever we want to ask something, and we try to address the questions live. So, without further ado, Edwin, the floor is yours, and we are kind of very curious to learn about the
yeah.
project and what you can do with it.
All right. Um, yeah, I would like to start with giving some overview of the reasons for creating this framework. Like for a year of five, I run a studio for interactive design and data visualization. Um, it's a studio based in The Hague, and pretty much every project that we do here either starts in software or is in the end produced in software. Also, in our way of thinking, creative coding is really our way of working and thinking. Um, that manifests in many different ways. So that ranges from like big media installations where we have like 8 projectors and there are sensors in the space. It's all real time. So we make spaces that they react to the presence of people in the space. Um, there's this another piece that works with sensors, and while making these kind of installations, we felt like there's no existing tooling that really supports the way that we work. So yeah, I started working on a library that was called RNDR at some point. And actually 5 years ago and 2 days, I open sourced the framework and we called it OpenRNDR. So in this framework, we can do like sketching, prototyping, and production. And it's also a framework that is constantly in development because every project that we do, um, we learn new things about doing that thing, or we need new tools. And you'll find that a lot of our ingredients are shared in this framework. Um, Next to the studio work, I also do a lot of in spare time. I make little drawings by programming in OpenRNDR, which is it's a really nice way of keeping yourself sharp, learning the ways that creative coding works, or it can work. So there's a lot of experiments, a lot of it's like for me it's like studying the topic of creative coding, and I like to share what I make on in this case on Mastodon. And it takes a lot of different shapes. I like to try out like as many things as I can, and you see that there's not really one fixed form for any of what I do. You see there's like a lot of animations. At some point we introduce like support for creating videos from OpenRNDR, and I will demonstrate a bit of that in the session. But what's really nice is that like anything that's on your screen, you can very easily turn it into videos, and even very easily into like perfectly looping videos. So that's a lot of fun. So when we open sourced the OpenRNDR framework, we also try to write a documentation for it, because a framework without documentation is pretty much not a usable framework. We put a lot of time and effort into this guide. You can find on guide.openrndr.org. And it shows like actually through animations and an example code how you can use it. And the guide is made with the idea that we maximize copy paste ability, right? So if you see something here that you like, you can just copy the code, paste it into your editor, and it will work most of the times. So this is if you're enthusiastic after today and you want to try it out yourself, I can highly recommend looking at the guides. Just browse through it and see how it works. Let's get started. We prepared an OpenRNDR template, and this is basically like where any of our own projects start. This is also like the advice way of starting working with OpenRNDR is start from the template. So the template is it's basically like a Gradle project. The project has it makes sure that you get all the libraries that you need, and it gives you like a very simple starting program. If I go to my IntelliJ, so this is I'm not going to show how to check out things, because I'm very, very anxious for IntelliJ going into this perpetual indexing mode that seems to happen sometimes. So let's skip that. But this is what it looks like after you have checked out the template project. You have like a thing that's called the template program, and if I run this program, we get this screen. So it's like an image, a text, and and a circle. So what I would like to do is basically throw away everything that we have here, and just
Edwin, can you make the ID screen full screen, or you're planning to use the right-hand side somehow?
Yeah, at some point I want to do this, but I can make it bigger now, and then I will reduce it at a later point in the session. I'm gonna do something here. So this is pretty much like the minimal setup of a program. So if we run this, we get like a window with this width and this height, and we would just see like a black screen. Right, so it would look like this. I'm gonna make my life a bit easier, and I'll set a position for the window. Right, now the program starts here, so I don't have to drag it from the other screen. Let's see. Like the first thing I'll do here is just clear the background into something that's pink, right? So that's that. Then my usual thing to show is how to draw a circle, which is like something that we saw in the last session as well. Circles, circles are easy and fun. Right, so now we have like a circle at this X position, Y position, and a given radius. And what is maybe interesting is to highlight some differences in the last session. There's like a lot of things that when you draw the circle, you would also specify the style of the circle. And the way that OpenRNDR does this is like a bit, I think it's a way that is actually shared by many creative coding frameworks, where you have a drawer, and the drawer has just like a bit of state. And one of the states it has is the appearance of whatever you're going to draw, such as a fill color, which I will now set to black. All right, so now the circle is black, and if I would draw another circle, say here, let's make it. Then that second circle is also black. So it has it has like a bit of memory. Whenever you set the color, it will remember it for the next things that you will draw. So also, if I would draw a rectangle, where would I place this? 100. Okay, yeah. So we have a rectangle, and some circles. There are some the other thing that you can set is the stroke color. And we can also set the stroke weight. 20 is a bit heavy. It's the same color as the background. Now, this also gives me like a bit of an opportunity to show something that I find really, really nice. One of our contributors actually went so far to create a plugin for IntelliJ, and you see here that I have in this gutter space, I have like little squares with a color. I can actually click on that square if the plugin is installed, and I can change the color, and I will update the code here with the color that I want. So it's nice. I find it really nice that I have previews of the colors. I have to say that myself, I don't really use this color picker, but it's really nice that it is there. Let's see. Yeah, there's also like a way to write texts. Add a position. Which it's drawer fill. Okay, just some very, very basic basic drawing. What I would like to do now actually is move away from this setup where I type code and I have to press start and I have to wait for the program to start. I want to demonstrate something that is the live coding mode. I will make a new file here. Live03. Which looks almost the same, but instead of having a program block, we have something that is called the Olive program. Let's reduce the amount of indenting. And when I run this, wait, let's okay. Right, so now I want to resize my window again. So I have now the IntelliJ and my program side by side. There's this thing, I skipped over it before, but there's something that's called a program. Basically, everything that is in here is executed once, and everything that goes in this extend block is called as many times as possible. So usually around 60 times per second. Let's try to do this. So you see that I changed the code here, and immediately the screen here updates. Actually, a pretty interesting way that this is done, because you see that I added .kt files, but yeah, somewhere on the background, we have a process that looks at if the kt file has been changed, then it finds where this Olive program block is, and it places this in a Kotlin script file, and that Kotlin script file is in the background. It's compiled, and basically the function that this Olive program block produces is then injected into the program. Yeah, what is nice now is that we can do all our drawing. We had before.
Sorry, Edwin, I wanted to ask a question. Like, for this olive oil program, when you do live reloading, for that, do you do any additional transformations using the compiler plugin, or it's pure automation with just I don't know, your tooling, your plugin, and so on?
Yeah, it's really only our tooling. So we try to stay away from compiler plugins or maybe even Gradle plugins. So it's just our program looks at this KT file, and in the background it does a bit of magic with the Kotlin script engines.
Nice, really nice.
Yeah.
There was also a question, why is it called Olive?
Yeah, for OpenRNDR Live. Yeah, I
Okay.
Yeah, let's see. So yeah, the nice thing with this is that we can now we can sketch a bit. So for example, if we want to make like a pulsing circle, we could do this. I'm going to make it pulse faster. So that's just drawing a circle. Yeah, like this is of course very, very simple. But I would like to show some things that that we have developed over time, and that I think are super powerful for graphics. So before I showed you how to just draw a circle directly to the screen, there's also, of course, like a circle as like a mathematical thing, or something as a a shape with which you can do calculations. So let's first make this circle again. So it's like this. And if we have a circle, we can ask for this circle to give something that is a contour. And I can draw this contour directly. So we just get the circle again. Actually, now it's using a different way of drawing the circle, because it's now using a vector representation of the circle. And then the other way, it was using like some optimized way to draw a circle. So we can draw this thing. This is like a contour. But on this contour, I can also ask for it, for example, to generate equidistant positions. So let's say I want to have 100 positions on this circle. And I want to draw those again. So here I make PTS, which is like 100 points. Then I have something that's called drawer circles, which takes like this list of points, and it takes a single radius argument. So now we have like 100 circles on top of the contour of that circle. We can make this like less or more, or we can even let's use something like mouse position.y to int. So now if I move it with my mouse, I have more or fewer circles. Then the nice thing is that the interface that drives all of this is contour. There are tools to make different contours. For example, there's something that's called a regular Polygon function, which takes like a number of sides, say 6, a vector for the center, so I use drawer bounce center, and a radius. So now we do the same calculations for equidistant positions, but equidistant positions it's agnostic to the shape on which it should calculate those. So I can make in this case a regular polygon with 6 sides, and we can just create points on it.
Really nice.
So this is super nice. Like there are other things that we can do with that contour. So now we draw like the full contour. Disable the fill for a bit. A contour, you can also take a subsection of it. So if I take from 0.0 to 0.5, then we have like only half of the contour. If I do this, and we have roughly a quarter of the contour. And we could also put in, for example, time. And then, wait, that is strictly plus. Then we have like a little walker. And it's now really easy to do, for example, like this. A for loop over it, and now we are drawing. This goes a bit too fast to my tastes. So anything here can just be changed, and so if you want 9 sides or 3 sides. I should be a bit faster because we don't see it.
So do I understand correctly? Whatever inside this extend block is, or Olive program actually,
Yeah.
is refreshed at whatever the frame rate is default, and can you configure that so that it's either slower or faster? Or I didn't get the update logic.
It's really because in most cases we want to draw every frame. There are very few cases in which we don't want to do this. So we basically have something that is, it's called a draw loop. This draw loop is executed as many times it can be executed. So if the refresh rate of your monitor is 60 hertz, this will execute 60 times per second. Unless what you do here is super heavy, then of course it slows down. But it's made to always redraw.
Okay, and you don't really need to control this, or you need, but it's kind of hidden, and
Yeah. Okay. So there are ways to control this. So there is a way to disable that it draws all the time. So if there's like a situation where you say, okay, we want to make something like a user interface, and I only want to draw when things have been changed in the user interface, then that you can disable that loop, and you can make something that triggers an update when it's needed. But since we use this for animation and interactive things so often, it's nice to have this as a default and disable it when you are in actually one of the edge cases.
nice.
I just want to show like one more thing with the contours that I find also nice. And that's actually there's the drawer has a bounce property, and the bounce property is a rectangle. So for that you can also get the contour, but you can also do things like there's like a scatter function, which is also available on anything that is like a contour or has like a shape. And scatter makes random points inside that shape. So. Yeah, now it's looks like snow. Let's try to freeze that. Because scatter uses a random number generator. What I want to do now is provide my own random number generator here, which every time I seed it with 0. So now it's frozen, and we see what scatter does. So you see these points here, and they are all roughly equidistantly placed from each other. So if I make this 10, you see what happens here. Now they will now they will overlap because the placement radius here is 6 and the radius of the circles is 10, so they overlap. But change this here then. Another thing that I find a nice display of features that nicely connect to each other. So if you have these points, there are ways to turn these points into a curve, for example. So there's like a function that's called hobby curve. A hobby curve is a specific kind of curve that tries to be nicely rounded on all places on this curve. and we can say okay, I want to make a curve from these points, and then yeah. So yeah, this is like it's like a curve. It goes through all these points. If I reduce the number of points, then yeah, it becomes a much more cleaner curve. Actually, this looks
So
nice.
it kind of generates the curve to go through all the points you have plotted
Yeah,
on the
yeah,
surface.
yeah. Since these points are like in random order, it's a bit of like a curve that intersects itself. But
Okay,
yeah,
that's interesting because the curve is curvy, obviously,
I,
but how does it calculate, let's say, between 2 points, how big the curve should be, why it's more curvy than the other curve on this line?
yeah, so I actually for this I don't know the exact geometric details, but what I think in some cases it tries to fit like circular arcs between points. It's actually a really complicated process, and I'm not entirely sure how this works. But there's also something nice there because I have a library function that does this for you, and the outcome is generally nice. But the exact details they are very hard for me to come up with them. So.
Nice.
But you can look in the source code if you want, or actually you can
Yeah.
also read the article that is written by the person that is called Hobby and
Oh, okay.
who developed this curve. Yeah, yeah, and yeah. So with this curve, you can do the same thing. So you've seen before. Yeah, it's really fast. Yeah, if you now hide the pointer. Yeah, this is kind of stuff that I really like, but looks organic. Doesn't look very made with a computer, and that's
Okay.
yeah,
Cool.
it's fun.
Is there a way to detect intersections of the line? So whenever the line intersects itself, um,
Yeah. There's actually quite an extensive library for working with curves. You can check for intersections. There is. Let me just try to show this.
because detecting the intersection would be a requirement for creating neural graphics, for instance, if you know what it means. I can show a picture. I draw
Yeah,
it
show it.
before the webinar. It looks like this.
Yeah.
So you see there's a lot of intersecting lines, but whenever the line is intersecting, it starts to melt somehow into each
Okay.
other. And this way you create this effects that you kind of create neurons on the drawing. So
Yeah.
that would be interesting to see if it's possible to program this kind of thing.
Let's see. uh, oh yeah, of course. Let's take this out. Not yeah. The problem is that like self intersections are like a bit tricky. Um, because now it finds like every intersection with itself, and you should
Uh-huh.
only find like very specific cases where um,
Yeah, it doesn't
where it
have to
really
be a self
intersects.
intersection.
Yeah.
It can be any geometrical intersection, like
Sure.
two circles when they intersect.
Yeah. Um, let's try this thing again. So I make this circle. Circle, and then I find the intersections between the curve and. Oh wait, I make a mistake here. It does work. Here,
Oh, nice.
I had a dumb mistake. Yeah.
Cool.
So it finds the self intersections very easily. Like it's really you take this one contour called subcurve. You take the intersections with subcurve, so with itself. Then you get what you get is a list of contour intersections, and then that means that for each intersection we know like a couple of things. So first of all, we know the position, but we also know where on the curve, where on the left-hand curve the intersection is, and where on the right-hand curve the intersection is. Which is for some situations that's really good to know, because maybe you want to cut the curve or the contour at the intersection, and with this intersection information you can do those things easily. Let's see if we can make it look a bit like how you had it in mind. Yeah, maybe if you.
Yeah,
There. Let's see. Yeah, it's not quite there yet, but I think it's a start for what you just showed.
Yeah. It's like surprisingly that you have this like built in basically into the framework. So it's just a matter of finding a way to kind of generically melt those edges at the intersection point, and then you basically get this neuron graphics done. Cool.
Yeah, I don't have because what you would need is like a variable stroke weights. It would be nice if you had a way to draw those easily, where you say, okay, at these intersection points the weight should be this much, and like just a bit away from the intersection points you want to have this fall off. I haven't encountered that problem yet, so there isn't there's nothing in my toolkit to do this quickly. But
or can you make a variable like weight of the line itself? When like you draw a line, it's always 1 pixel, but can you make it like variable width?
not with the default vector drawing tools, but there are ways to do this. I think the most common way to do this is you make a new contour, but that's not just a curve, but it's something that has like an area, right? So you actually make a polygon over the contour that you're making, and then you can draw it with the existing vector drawing tools. Another way to do this would be to let's try something. Other way to do this would be to draw a lot of circles, and circles would be the radius of the circles would be determined by how far away they are from an intersection.
Oh yeah,
but I don't think I can show that in quickly in this session. But basically with the things that I showed with the equidistant positions function. If I just take like a lot of points, even more. Yeah. Okay. Yeah. Now we barely see that they are circles. Maybe just a bit more. 5,000. Okay. Then curve. Oh,
Okay.
way too fast. Yeah, you see, like now there's like a curve
Ooh.
with variable width, but it's only because I approximated yeah, using circles. I'm gonna make this a bit slower. Yeah, and yeah, if we were able to quickly find the distance to the intersections, then you could scale this. Yeah, you could make the size depend on the distance to the intersections. Let's try something. I'm being tricked into trying this anyway, wait, I need something extra. Wait.
There was I think a relevant question if it works only with the curves, if the intersections just work with the curves.
Mm-hmm.
And I guess we have an answer that it works with whatever shapes that have a contour property.
Yeah, if you want to test against a box, you make a contour that represents a box, and then you can find intersections with that. So it's yeah, as long as you can represent it as a contour, you can intersect with yeah, with anything you want. Yeah. Meanwhile, I changed my setup to include an extra library. So the OpenRNDR framework is organized in yeah, a core library, which is just called OpenRNDR. And there is something that is called ORX, which stands for the OpenRNDR extras. Most of them are yeah, community contributed libraries. One of the libraries that is in here is one for KD trees, which is a way to if you have like a set of points, you can very quickly ask for the nearest point. So you have like a query point, and you want to have the nearest point in the set of points. So I thought, if I make a KD tree from my intersection points, and I would maybe here, let's see, KD tree, let's find nearest. So for every circle that I draw, I want to, from that position of the circle, I want to find the nearest intersection point. And then I do something like the distance to that point. Hey, why are you? Yeah. there is always a point. Okay, then that distance is going to be exactly the opposite of what we want to do. This is not going to work. Oh, yeah, closing. Yeah, this distance, now it's larger. Points that are further away from an intersection point are now drawn with a very large radius, and we actually want to have the opposite. So I'll just try something like the exponents. Times 1 times 10. Yeah,
Oh,
it's
nice.
not bad. It's not bad for a first shot. Well, yeah, you tricked me into doing
Cool.
this, and I think I delivered. So
That counts. That counts.
cool. I had a lot of other stuff on my schedule to show, but I also see that we're pretty far into our time.
Yeah.
Actually, what I would like to show maybe now is how to turn this into a video or into an image. So what I will do is I take the live mode out just for this, and yeah, you see here we have like an extend thing, which is in this extend block we provide all the user code, but there are also ways to extend a program with like existing library code. So one of the tools that is very, very nice for this is called the screen recorder. And we can program the screen recorder for, say, just record 10 seconds of this. So now it shows the output, but it's also creating a video file. And we see it here. And there it is, like a video file of whatever you have made.
Nice.
Yeah, so
At every step when you show something, I have a million of ideas and questions like, does it do this and does it do that? So currently you've been showing like how to get a visual image in front of you and basically animate it and save it somehow. But as you mentioned, OpenRender is a framework that integrates with some other things. And if we talk about creative coding, we can actually think not only about the images or graphics, we can think of music.
Yeah.
So I just had this idea right now. Probably it works, probably it doesn't. Maybe it's a dumb question. Do you have a MIDI integration?
Yeah, so we have several tools for this. So there's an integration where you can connect MIDI controllers to your program. I think there's also a way to be the MIDI controller from OpenRNDR, so that you talk to a sequencer or like a synthesizer, and you can drive it. There's also something that's called OSC, Open Sound Control, which is which some software uses. It does something similar to MIDI, but it's much more much more extensive. So yeah, that is possible, and I know of some people that use this to drive sound. Or actually, I've also done this myself in some work. Yeah.
Cool, nice. So it's possible two ways. You can get the sound in and the picture out, or you can generate the picture and generate the music somehow, or like it depends how you create the rules, right? You
Yeah, I mean, it's you're not really there's nothing really in OpenRNDR that limits you from how you want to use it. So if you want, you can like say broadcast MIDI into another software that's like that generates the sound, or you could use existing libraries that can produce sound. Yeah, on the JVM. That's also possible, and that would all work pretty well. So you can make something that makes the sound and the visuals from the same parameters. That's absolutely possible. Yeah.
right. The question was because I play with MIDI myself. Like I do have synthesizers, I do have MIDI keyboards, and I
Mhm.
sometimes would like to visualize it as well,
Yeah.
like program it myself and see how it reflects. Like if I change the tempo, if I change the pitch, if I change play with the oscillators, how does it,
Yeah.
reflects in the screen? That would be really cool
Yeah.
to see and make.
Yeah.
Right.
Maybe
Cool.
maybe in the next session
we
we can
can
try
we
to
can
do
try
this.
that. We can
Yeah.
definitely try that. And I think, let us know in the chats and in the comments to this video, everybody who's watching this session, either live or recorded. Please let us know, and we probably can schedule something around music with Open RNDR and Kotlin. And our kind of webinar is getting to an end today, but we probably wouldn't be able to show anything too big, too extensive right now. But I do have a few questions, regarding Open RNDR again. Like it's a framework created in Kotlin
Hmm.
for Kotlin developers, basically. Why did you decide to implement it in Kotlin, not in any other language? Because the other frameworks I have seen that are popular enough are either JavaScript or even C++ sometimes.
Yeah. That's a good question, and I think it actually has to do with yeah with work. So there's a time in the past where we tried to work with processing, and we were in a situation where there were people that were really excited about programming, but not to an extent that they could use languages like C or C++. And Java was back then, together with processing, was a really good and safe environment for people who are learning programming. I think the tools around the JVM are really good for telling you what it is that you have done wrong. Um, so yeah, we started as like a shop that use processing. Then we kind of grew out of this processing environment. Our work became too complex to manage uh, with that tooling. So we started rolling our own, and actually that started as a Java project. And at some
Hmm.
point, Kotlin, I think there was just like the first 1.0 release. It came on my radar. I tried it. I was really blown away by the Java and Kotlin interop. And the Kotlin language was like really a nice language to work with. So I slowly moved everything into Kotlin, and
Cool.
yeah, there's
Really
that. And
cool.
I have to say the Kotlin language has so many really nice features for creative coding. Like there's of course like all the type safety that you have when you work with Kotlin, but there's also the DSLs, which we use extensively without really saying what they are. But I find like this DSL approach works really nice. Also, if you explain it to newcomers, it's like, there's sort of like this structured document, and you just have to place your drawing code here and there, and yeah.
Now, we have a contribution question. Like, what's the good way to contribute? I guess it's like with the other open source project, maybe there is some specifics you can add.
Ooh, well, there is actually. I tend to start a lot of like a little little branches within the OpenRNDR project, and one of the things that I have started, I think now it's even 2 years ago, was a WebGL implementation of OpenRNDR. So OpenRNDR with Kotlin, you can compile to JavaScript, and you are sort of able to run things in the browser. It's just that, yeah, the amount of time that I have at this point is not big enough to support this thing. So if anyone feels like yeah, making contributions to this part of OpenRNDR, I would be really happy. And besides that, I think you can also contribute in many other ways. There's always the writing of documentation, or if you see like a way to write an extra for OpenRNDR that provides like certain like a
Even the
geometric
curves.
thing.
Yeah,
Yeah, like there, like, that's also a lot of those things are community contributed, and it's nice to add those to the toolkit, definitely.
cool. Cool. All right. That was amazing. I say, like, with this little amount of code to create these stunning pictures is like, I don't know, like compared to Jetpack Compose, where you do everything by hand and you learn geometry to actually implement it. You have a toolkit that just does it for you, and that's amazing. And thank you, Edwin, for coming. I'll be sure to contact you again to schedule another session. I think everybody is excited about this, and yeah, stay tuned, everybody, and that would be awesome.
All right. Thank you so much, and yeah, I hope you will try some OpenRNDR yourself soon. And if you have any questions, we also have an OpenRNDR Slack, um, where I will happily answer anything you ask. Cool. Thank you.
Cool. Have a nice Kotlin, everybody.